what we are going to discuss here, that how to calculate the area in the evaporator. That is the main point of our discussion, because कुछ numericals पहले भी आए हुए हैं और आने वाले टाइम में और numericals आ सकते हैं for calculating the area. In 19 there was a question based on this multiple effect evaporators. Okay, so not in 19, I guess in 20, right? तो फर्स्ट ऑफ ऑल थोड़ी सी इनकी रीजनिंग भी समझनी है, सिंगल इफेक्ट, मल्टीपल इफेक्ट, फॉरवर्ड फीड, बैकवर्ड फीड, वो सारी बातें करेंगे. ओके, बट बिफोर दैट यू मस्ट नो दैट व्हाट इज द डिफरेंस बिटवीन इवापोरेशन एंड बॉइलिंग. इवापोरेशन एंड बॉइलिंग. ओके, एंड देन यू शुड आल्सो नो द डिफरेंस बिटवीन इवापोरेशन एंड ड्राइंग. So evaporation and boiling के बीच में बहुत एक स्टैंडर्ड डिफरेंस है, राइट? आई मीन आप सभी लोग जहां भी पूछोगे, जहां भी आप पढ़ोगे, आपको एक ही डिफरेंस मिलेगा, दैट इवापोरेशन इज अ सरफेस फिनोमेना व्हाइल बॉइलिंग इज अ बल्क फिनोमेना, राइट? सो दैट इज द डिफरेंस. लिख लो दैट इवापोरेशन इज अ सरफेस फिनोमेना. इवापोरेशन इज अ सरफेस फिनोमेना व्हाइल बॉइलिंग, सरफेस फिनोमेना व्हाइल बॉइलिंग is a bulk phenomena. Is a bulk. What is the meaning of this line? Evaporation में केवल surface, जो liquid surface पे molecule है, only those molecules are taking part in the evaporation. While in boiling, we say that boiling is occurring, or boiling has occurred only if the entire bulk is involved in this process. Secondly, that evaporation can occur at any temperature. While boiling के लिए आपको that entire liquid has to reach at that particular boiling point of that liquid, right? So you can say that evaporation can occur at any temperature. अब बोलोगे सर क्या evaporate करने के लिए boiling point तक जाना जरूरी नहीं है? No, you can see the sea water. You know that the sea water continuously, or a water in a river continuously evaporates. But if you put your finger inside that water of sea water or river water, it is not present at the boiling temperature. So the surface molecules of river water or sea water or a pond or a lake, they are having sufficient energy to go into the vapor phase, right? Only the surface molecules. So evaporation can take place at any temperature. Can take place even, मतलब आप बोलोगे सर क्या मतलब कि 5 degrees पे भी evaporation होता होगा? Yes, some extent of evaporation is there. Some molecules are always having sufficient energy which can go into the vapor phase. Evaporation can take place at any temperature. At any temperature, while boiling can't. At any temperature, while boiling requires the entire liquid to be present at a specific temperature. ये दो main difference है. Entire liquid to be present at specific temperature. Present at specific temperatures. Okay. Specific temperatures. ठीक है बात? These are the two major differences between evaporation and boiling. बाकी छोटे मोटे कुछ difference हो सकते हैं. Now the question arises कि sir what is the difference between evaporation and drying? Now यहाँ पे थोड़ी confusion हो सकती है, because sometimes you may see that in drying topic it is written that the moisture in the solid is evaporated. तो drying में ही आप evaporation word का use कर ले रहे हो. So they are actually having similar meaning, right? तो evaporation and drying में ऐसा कुछ phenomena का difference नहीं है. Evaporation and drying are almost having same meaning. But drying is generally, the drying word is not used when you have a liquid which is vaporizing. Drying word is used when removal of moisture is taking place from the solid. But of course, for removal of moisture, the moisture is getting evaporated into air. So drying word is with respect to solid, right? आप ऐसे नहीं बोलोगे that suppose a liquid is there in a container and the liquid is evaporating. आप नहीं बोलोगे the liquid is getting dried. ऐसा बोलोगे क्या? नहीं. So drying word is particularly used when moisture is getting removed from solid by evaporation. तो ड्राइंग और इवापोरेशन में डिफरेंस क्या है? ये सवाल बहुत ज्यादा सही सवाल. दिस इज नॉट द राइट क्वेश्चन एग्जैक्ट. दिस इज नॉट द एग्जैक्ट क्वेश्चन दैट व्हाट इज द डिफरेंस बिटवीन ड्राइंग एंड इवापोरेशन. बट स्टिल सम पीपल who wants to show you that you don't know anything, they may ask you, they may poke you कि नहीं बताओ तुम्हें तो कुछ नहीं आता. What is the difference between drying and evaporation? Then for that kind of situation, your answer should be drying is referred to as removal of moisture from solid, while evaporation, normally when we say evaporation, we are referring to liquid, right? The surface molecules of liquid are evaporating. So when there is a liquid body evaporating into air, we use the word evaporation. When the moisture is removed from the solid, we use the word drying. बट अगेन आई एम सेइंग दैट कई बार ऐसे लिखा होता है ना, दैट द मॉइस्चर इज इवापोरेटेड फ्रॉम द सॉलिड एंड हेंस द सॉलिड इज ड्राइड, करेक्ट. सो बट स्टिल फॉर आवर रिकॉर्ड्स आई एम डिस्कसिंग द डिफरेंस बिटवीन इवापोरेशन एंड ड्राइंग. तो यहां पे बस यूज की बात है, फिनोमिना तो सेम ही है, राइट. इट्स जस्ट अबाउट वेयर वी यूज द टर्म ड्राइंग एंड वेयर वी यूज द टर्म इवापोरेशन. सो moisture removal from solid, moisture removal from solid is referred to as drying. And when moisture removal from liquid, this kind of statement we don't usually give when evaporation is taking place, कि moisture is removed from the liquid, ऐसा statement सही नहीं है, right. So moisture removal from solid is referred to as drying, while evaporation word is more common when a vapor is produced from a liquid, right. While evaporation word is used for vapors coming out of a liquid, right. For vapors coming out of water. यहाँ पे एक और डिफरेंस आपको बता दूं, coming out of water. When it is water, we use the word evaporation, but when it is any other liquid, we use the word vaporization. Phenomena is same, but it's all about the which particular word is suitable for what situation. तो अगर आपसे कोई पूछे evaporation and vaporization में क्या डिफरेंस है, again it's all about in which situation we are using it. Otherwise things are same. The liquid is getting converted into vapor. So evaporation and vaporization. So what is the difference? When it is water, we use the word evaporation. When other liquids, mostly the organic liquids, we use the word vaporization, right. So for water is going to vapor, we use the word evaporation. For other liquids going into their respective vapor form, we use the words vaporization. Okay, so what is this? Vaporization. And what is this? Evaporation. It's all about where is the proper use. Otherwise there is no strict rule for this. आपको लिखे हुए मिल जाएंगे words. कई बार बुक्स में आपको drying and evaporation simultaneously. I am telling you that evaporation of moisture from a solid leads to drying of the solid. अब वहां आपको परेशान होने की जरूरत नहीं है. This definition, these differences I am just listing out for the records कि हाँ मैंने भी पढ़ा है. अब ये मैं आपको बता रहा हूं ना कि ये वही लोग आपको परेशान करेंगे जिनको दिखाना है कि यार तुझे कुछ नहीं आता और मुझे बहुत कुछ आता है, राइट. तो ऐसे लोगों को आप लाइफ में इग्नोर करते चलो. योर कंपेरिजन, योर डेवलपमेंट इज विद रिस्पेक्ट टू योर सेल्फ. डू नॉट कंपेयर योर परफॉर्मेंस, योर नॉलेज विद समवन एल्स. खुद देखो कि कल कहाँ थे, आज कहाँ हो, दैट्स इट. और काम करते चलो. ये फंडा आपको लाइफ में मतलब अपने अंदर लाना पड़ेगा. आप आज नहीं तो कल ले ही आओगे, राइट. मैं भी पहले ऐसा नहीं था, बट लेटर आई रियलाइज्ड कि दूसरों से कंपेयर करके कोई फायदा नहीं है. many of my friends were one of my, in fact he was my close friend in BTech. He was, I think I gave his example many times. He was selected in IUCL in the passing year only, 2013, when I did not know anything about chemical engineering. Most of the subjects I was zero, almost zero. अगर कंपेयर करता रहूंगा तो फिर मैं आज शायद यहाँ नहीं होता. Then I thought कि ओके उसको जाना था, हो गया, right. I took a drop. I was not preparing for GATE. Actually I was teaching chemistry. But somehow in the month of November, December, I thought कि okay ठीक है, कुछ ना कुछ तो करना ही है, चलो GATE पढ़ लेते हैं. I prepared for GATE, got into IIT Roorkee. And during my MTech, I prepared all these subjects. Nobody was there to teach me. किसी टीचर ने आके नहीं कहा था कि नहीं ये काम करो, चलो अब मैं तुम्हें थर्मो पढ़ाता. Even in IITs, nobody is going to teach you. आपको खुद रियलाइज करना पड़ेगा कि I have already spent my 4 years in my BTech. After that 1 year, I have taken a drop. अब नहीं पढ़ूंगा तो कब पढ़ूंगा? When I am going to understand all these subjects. Otherwise, there can be one more way that you leave all these subjects. There one of my friend in final year, he told me कि यार पांडे ये temperature pressure बहुत हो गया. Now I am going to prepare for SBI PO. Okay, he chose his path. It's perfectly all right. मैं कभी नहीं कहता that going for MBA is fine or going for SBI PO is fine, going for UPSC is fine or going for GATE is fine. But the thing is, you should make your decision at the right time. राइट टाइम पे डिसीजन नहीं होगा, यू आर गोइंग टू फेस डिफिकल्टी एज आई फेस्ड. मेरे कभी भी डिसीजन राइट टाइम पे नहीं, माई डिसीजन वाज करेक्ट बट ऑलवेज लेट, नेवर एट द प्रॉपर टाइम. सो प्रॉपर टाइम पे डिसीजन ले लो. पढ़ना है तो पढ़ना है, फिर उसमें इफ एंड बट ऐसा नहीं, पढ़ना है उसको, राइट. सो यही है कि वही मैं आपको बता रहा हूँ, दीज आर सम डेफिनेशंस. इनको लेकर परेशान नहीं होना कि सर नहीं आपने ये बताया था कि ये तो अलग अलग है, बुक में देखो सेम लिखा हो. ये क्वेश्चंस गेट में कभी नहीं आएंगे, कभी नहीं आएंगे. दीज आर जस्ट फॉर योर नॉलेज, क्योंकि दीज आर सम कंट्रोवर्शियल क्वेश्चन. फॉर समवन ड्राइंग एंड इवापोरेशन कैन हैव द सेम मीनिंग. इनकी कोई स्टैंडर्ड डेफिनेशंस नहीं है. दीज आर जस्ट फॉर योर अंडरस्टैंडिंग, राइट. क्योंकि कई बार मैंने देखा है कि मैं पूरी इवापोरेटर समझा देता हूँ, फिर आता है बच्चा कि सर वो उस वाले सर ने इन बच्चों को देखो बॉइलिंग और इवापोरेशन में डिफरेंस बताया और आपने नहीं बताया. दीज आर नॉट इंपॉर्टेंट थिंग्स फॉर गेट, राइट. But for the records we have discussed. Okay, now let's talk about that how evaporation takes place. My focus is the design of evaporators, right? So let's discuss few things on the basis of number of effects. Effects means actually there are sometimes we use multiple evaporators. Sometimes we use single evaporators, right? So on the basis of number of effects, we have two types of cases. One is single effect evaporator. Only one evaporator will be used, and one is multiple effect evaporators. Single effect evaporators, and one is multiple effect evaporator. Multiple effect evaporators. ठीक है. How many evaporators you have? Suppose if you have only single evaporator, it is called single effect. If you have multiple evaporators connected in series, I'll tell you that what are the ways in which the evaporators can be connected. I'll show you the proper diagram, right? But if you have more than one evaporators connected in series, it is called multiple effects and single effects. Okay. Now the question arises कि because इस पे theoretical question बनते हैं कई बार, out of single effect evaporator and multiple effect evaporator, which one is more beneficial? Right? और ऐसा भी नहीं कह सकते more beneficial, because in one aspect if you are getting benefit, then in other aspect you will be facing a loss, right? हो सकता है ना, in one aspect in terms of production you are getting benefit, but in terms of energy cost you are getting a loss. So ये ऐसा नहीं कि सर single effect is better और multiple effect is better. इस तरह के weird question या vague question मत पूछा करो, right? There is no meaning of asking this question that sir which reactor is best, right? Which evaporator configuration is best, which heat exchanger is best. There is not, ultimately final decision I always say is taken on the basis of cost and safety, and cost and safety I can't calculate by using the concept of heat transfer. मैं कर ही नहीं सकता. ये तो आप तभी करोगे when you are into the real world. So these kind of questions should not be asked. It's all about the particular case. In this case also, when you're going from single effect to multiple effect, in one case you'll be facing some profit, some advantage, while in other aspect you'll be facing some loss. Okay, but still, what is the difference between these two? What is the actual difference? So for understanding the difference between single effect and multiple effect, I'm going to define few terms, right? Terms related to, because once you understand the definition of these terms, then only we can talk about single effect and multiple effect. Okay, so terms related to performance of the evaporator. Performance of evaporator. How, on the basis of what parameters we decide that this evaporator performance is better than the other. Okay. So first of all, there is one term called, these are very important, there is one term called steam economy. Steam economy. और ये definition चाहे आप multiple effect की बात कर लो या single effect की बात कर लो, the definitions are same. So we will compare them later. First of all is steam economy. What is steam economy? You know that in evaporation, I told you that we are trying to produce vapors, right? We are trying to produce. What is the purpose of evaporator? Sorry, to evaporate the water from the solution and to make the अब यहाँ पे एक और difference आ जाएगा. Sir, what is the difference between evaporator and boiler? They are doing the same thing, but the purpose is different. In evaporation, the purpose is to make the aqueous solution concentrated, while in boiler, the purpose is to generate steam. These are the names given for different purpose. तो अगर आप इसको इन तरह के क्वेश्चंस पे आओगे तो इस तरह के डिफरेंस मिलेंगे. You know that in both the cases same kind of process is happening. Same mass transfer, same heat transfer is happening, right? So terms related to performance of evaporators, first one is steam economy. So in any evaporator, steam is used. Steam is right down here, that in any evaporator, in an evaporator, steam is used. Steam is used. Now ये steam करती क्या है? Steam loses its heat. Most of the time it's latent heat only, but it should be given in the question that what kind of heat it is losing, right? Steam is used which loses its heat, mostly the latent heat, should be provided to evaporate water. To evaporate water, right? So steam ने use किया. Now the thing is, steam economy is defined as kg water evaporated per kg of steam used. Okay, so we define this steam economy as how much kg of water you have evaporated. Kg water evaporated per kg of steam used, right? Per kg of steam used. 1 kg स्टीम जो आपने यूज किया उसकी हेल्प से कितना वाटर इवोपरेट. यू विल से कि सर 1 kg से क्या 1 ही kg इवोपरेट होगा? No, it is always less than 1 kg. But अभी बात करते हैं that we are talking about single effect or multiple effect. But for now, one parameter is the steam economy, right? The other parameter is second parameter after economy. We have one more parameter that is called capacity, right? That is called capacity of evaporator. So what is capacity? Capacity of evaporator is defined as kg water vapor produced. Steam produced, steam is getting used. So kg water vapor produced per hour. अच्छा, R की जगह मिनट भी हो सकता है. That is not a big deal. kg water produced per unit time is the capacity, right? So kg water, अच्छा, water evaporated or water produced, they are the same thing, right? So आप यहाँ kg water evaporated भी लिख सकते हो, doesn't matter. Okay, and if you talk about a third term, it is called consumption. Consumption is basically steam consumption. So steam consumption and steam economy are different thing. If you take a ratio, consumption means how much steam your evaporator is consuming per unit time. So if you take a ratio of what do we want? We want this. Okay, if you take the ratio of capacity by economy, you can see that consumption is equal to capacity by economy. ठीक है? Capacity is kg water vapor or kg water evaporated per hour, and economy is kg water evaporated per kg steam used. So ultimately you will be getting kg steam used per hour. So that is the third term. तो ये तीनों लिख लो. पहले गेट में इनकी डेफिनेशंस आ चुकी हैं. स्टीम यूज्ड पर आवर. देखो, जो पोर्शन में आपको हीट ट्रांसफर में किसी भी सब्जेक्ट में पढ़ा है, आपको ये फील होगा कि जस्ट बाय वाचिंग द क्लास लेक्चर्स यू कैन सॉल्व 60-70%. मैं कम बता रहा हूँ फिगर्स, मैं ज्यादा ही होगा. यू कैन सॉल्व 60-70% ऑफ द गेट प्रॉब्लम्स. आई मीन यू वर इन अ सिचुएशन जब आपसे प्रॉब्लम सॉल्व नहीं होती थी, एंड आफ्टर वॉचिंग दीज लेक्चर्स यू कैन सॉल्व 60-70% ऑफ द प्रॉब्लम. I know that always there are 25-30% problems where you are facing doubts, and we are also trying to clear all those doubts. And you will feel that when you are preparing for, when you are going to appear for the examination, still there will always be 3-4 questions. There will be, suppose for in a subject like heat transfer, there can be 10 questions for which the proper explanation you are not able to get. Don't panic, उसको छोड़ दो, कोई बात नहीं. There are always some questions, ठीक है? कुछ questions तो ऐसे हैं कि जो कि गलत है, और कुछ क्वेश्चंस ऐसे जिनके लिए एक्सप्लेनेशन प्रॉपर नहीं मिलता. तो जब तक प्रॉपर एक्सप्लेनेशन नहीं मिलता, इट्स माय वर्क कि मैं उसके पीछे लगा रहा हूं, ढूंढता रहूं. मिल गया तो ठीक, नहीं मिला तो भी कोई दिक्कत नहीं है. एक प्रॉब्लम की वजह से आपका पेपर नहीं बिगड़ने वाला, राइट? बट द सेकंड थिंग कि कई बार मैंने ये देखा है कि यू ट्राई, या कई बाकी लोग भी ऐसा करते हैं कि उस प्रॉब्लम को बस ये बताने के लिए, हाँ मैंने ये भी प्रॉब्लम कराई, दे ट्राई टू गिव यू द रॉन्ग कॉन्सेप्ट्स. ऐसा रॉन्ग कॉन्सेप्ट नहीं देना. जो मैंने क्लास में पढ़ा है इसी लॉजिक से मैं सारे क्वेश्चन सॉल्व करवाऊंगा. अगर नहीं होता है सॉल्व, इसका मतलब उस क्वेश्चन में कुछ प्रॉब्लम है, या हो सकता है कुछ लॉजिक कहीं पे हम लैग कर रहे हो. इट्स माय जॉब कि मैं उस क्वेश्चन के पीछे भागता रहूं. मैंने पहले ही बताया कि मैं हमेशा क्वेश्चंस के पीछे भागता हूं. अगर कोई क्वेश्चन मुझे ऐसा मिल जाता है स्टूडेंट्स ऑल्सो कीप मी आस्किंग सम क्वेश्चंस, आई ऑलवेज स्टार्ट थिंकिंग अबाउट दोस प्रॉब्लम्स, ठीक है, और कभी ना कभी मैं देखा हमेशा ऐसा होता है कि उसका सोल्यूशन मिला है, प्रॉपर सोल्यूशन, ठीक है, विद प्रॉपर रेफरेंस ऑल्सो, आई ऑलवेज लुक फॉर रेफरेंस, बिना रेफरेंस के ऐसा कम होता है कि हाँ, इफ आई डोंट हैव एनी आइडिया अबाउट अ पर्टिकुलर कॉन्सेप्ट, आई ऑलवेज लुक फॉर सम रेफरेंस, ओके, सो दैट शुड बी योर नेचर ऑल्सो, बट बिकॉज मुझे तो पढ़ाना है, तो दिस इज माई जॉब, बट आपका काम एग्जाम देना, तो आपको उसकी टेंशन नहीं लेनी कि सर दीज 10 क्वेश्चंस, अरे बाकी हो गए, देखो यार तुम कहाँ थे इस टाइम में, आपसे क्वेश्चन नहीं बन रहे थे, और अभी आप 99% क्वेश्चन, 98% क्वेश्चन ऑफ प्रीवियस ईयर यू हैव डन, दैट इज मोर देन सफिशिएंट, ओके, सो प्लीज राइट ऑल दीज डेफिनेशंस, three parameters to evaluate the performance of evaporators: economy, consumption, and capacity. Okay. Now let's talk about the single effect and multiple effect. Why someone wants to go from single effect and multiple effect? Okay. First of all, अभी मैं आपको feed arrangement of evaporators के बारे में बताऊंगा, but before that, if you talk about single effect evaporators, single effect evaporators, okay, right, you can write here that economy means steam economy is always less than 1. Economy is always less than 1. I'll also discuss the material and energy balance on evaporators, don't worry, तो मैं diagrams वगैरह बनाऊंगा, but पहले थोड़ी सी जो फीड अरेंजमेंट्स हैं उनके बारे में डिस्कशन कर ले, राइट। सिंगल इफेक्ट इवेपोरेटर्स, इकोनॉमी इज ऑलवेज लेस देन 1. कैपेसिटी वी कांट से लेस देन 1 मोर, कैपेसिटी कैन बी एनीथिंग 10 kg per hour, बिकॉज इकोनॉमी इज अ रेशियो, राइट, एंड इकोनॉमी डेफिनेटली फॉर सिंगल इफेक्ट इवेपोरेटर्स इज लेस देन 1. Now, when we talk about multiple effect, there was a question in GATE that why we go from single effect to multiple effect. So there is specific advantage that choosing multiple effect evaporators, over single effect, choosing multiple effect evaporators over single effect has a specific advantage. What is that? ये एडवांटेज समझने के लिए पहले आपको समझना पड़ेगा कि मल्टीपल इफेक्ट में कॉन्फ़िगरेशंस क्या क्या होती है ना. देयर आर वेरियस 3-4 टाइप्स ऑफ कॉन्फ़िगरेशन, बट राइट नाउ आई एम गोइंग टू डिस्कस ओनली वन कॉन्फ़िगरेशन. सी, दिस इज अ पर्टिकुलर टाइप ऑफ कॉन्फ़िगरेशन. अभी इसका मैं नाम नहीं बता रहा, बट लेट्स से दिस इज फर्स्ट इफेक्ट, राइट. इफेक्ट 1 मींस द फर्स्ट इवेपोरेटर. दिस इज द सेकंड इवेपोरेटर, राइट, एंड देन द थर्ड इवेपोरेटर. ठीक है. वन क्वेश्चन आई वुड लाइक टू आंसर हियर. दिस इज द थर्ड इवेपोरेटर. अभी मैंने जस्ट बेसिक डायग्राम्स बनाया, जस्ट बेसिक डायग्राम, एंड अभी मैं आपको फीड अरेंजमेंट भी अभी नहीं बता रहा, राइट, क्योंकि फीड अरेंजमेंट मुझे कोई ना कोई अरेंजमेंट तो लेनी पड़ेगी ना फॉर एक्सप्लेनिंग द कॉन्सेप्ट. ओके, सो चूजिंग मल्टीपल इफेक्ट इवेपोरेटर ओवर single effect has a specific advantage. What is that advantage? Let's see. Okay. Right. So, yeah. I was answering a particular question that how we number the effects. I mean, it is always from left to right, or what is the rule? So, please note that the effect in which, this is important for you to understand, in which ये हमेशा valid होगा, not only this configuration or every configuration, in which the steam enters first, or the effect in which the steam enters is called first effect. तो steam के हिसाब से effect होता है, feed के हिसाब से नहीं होता है, is called first effect. The effect in which the steam enters is called the first effect. Suppose the steam is entering from the left side and the feed is entering from the the right side, then this will be called as first. Suppose if the steam is entering from here, the feed is entering from here, this will be called as first. So this your concept must be clear, right? Okay. Now this is first evaporator. Suppose the feed is entering from here, correct? The feed is entering, और इसी evaporator में मैंने steam भी enter कराई. Now what happens that the stream is entering. This is feed. अभी मैं आपको सारे configurations बता दूंगा, don't worry. This is stream. Feed is entering. steam is entering. Okay, so the steam evaporates the water in the first effect and itself it is going to condense. Of course, the steam is going to condense, you know. ठीक है, तो steam जो condense होगी वो यहाँ से बाहर आ गई. Okay, condensate यहाँ से बाहर आ गया. Now, the water vaporized from the first effect goes here, right? While the liquid coming from the first effect goes in this evaporator. Okay, the liquid coming from the first effect goes into this evaporator. This liquid, अब इसको heat करने के लिए in the second effect I am not introducing steam again, while this vapor which is leaving the first effect is used to heat this liquid present in the second step effect. Again, it will produce some vapor and this vapor is also going to condense. Don't worry, ये condense होके बाहर आ जाएगा, इस liquid में नहीं मिलेगा. This will condense and it will come out, right? So what do you observe? That this liquid goes into the third evaporator and it further, okay, the vapor coming from the second evaporators is used to vaporize some more liquid in the third effect, and then you have the final product. This is a kind of particular kind of arrangement. I'll talk about that arrangement, don't worry. Okay, so what do you see here? That steam, what is the definition of economy? Kg vapor produced per kg steam used. Now see, obviously I am using steam only once in this effect only, while vapor is getting produced here. ये तो condense हो गया, then with using this heat, vapor is getting produced here, vapor is getting produced here. So if I define economy, then kg vapors produced is this plus this plus this. भाई ये भी तो vaporize किया ना मैंने. Later it is getting condensed, it is coming out of the system. भाई ये बाहर देखो, ये ऐसा liquid में जाके mix नहीं होता. This is not direct heat transfer. This is indirect heat transfer. This will condense out and it will go out, right? Ultimately, my solution is getting concentrated. So, in this case, only 1 kg steam, or suppose steam is used only once, but vapor is produced 3 times. So, what is the main reason that why we go from as a specific advantage that multiple effect evaporator, evaporators have more steam economy. This is the reason that why we are going, because steam का cost ज़्यादा. Of course आप बोलोगे सर evaporator भी तो लगा दिए थे, उसका भी cost होगा. No, we can't compare cost. But if someone asks you that why multiple effects, this is the reason. Multiple effect evaporator have more steam economy. And of course this steam economy will be greater than 1 as compared to single effect evaporator. As compared to single effect evaporators. One reason, ठीक है, सिंगल इफेक्ट इवेपोरेटर्स. ये क्वेश्चन आया हुआ है दैट व्हाई वी गो फॉर मल्टीपल इफेक्ट इवेपोरेटर, व्हाई वी चूज. यू कैन सी योरसेल्फ इन मल्टीपल इफेक्ट स्टीम तो भाई एक ही जगह एंटर हो रही, एंड इन अदर इफेक्ट्स द वेपर्स फ्रॉम द प्रीवियस इफेक्ट इज यूज्ड टू हीट द लिक्विड टू वेपराइज द लिक्विड इन द नेक्स्ट इफेक्ट. दैट इज द एक्चुअली मेन advantage of using multiple effect, that in the first effect only steam is used, while in the consecutive, in the upcoming effects, the vapors coming from the previous effects are used to vaporize more water, right? तो लिख ही लेते हैं, लाइन लिख लेते हैं. In multiple effects, this is the advantage, right? In multiple effects, effect evaporators, steam is fed only to the first effect, while the vapors, while the evaporation of water in the upcoming effects, evaporation of water in subsequent means next in subsequent effects is done by vapors produced from the previous effect. Vapors produced from the previous effects. ठीक है, ये ठीक है. दैट इज द मेन कॉन्सेप्ट ऑफ मल्टीपल इफेक्ट्स. दिस इज वाई वी गो, ठीक है। ऑफ कोर्स आप बोलोगे सर इन दिस केस ऑफ मल्टीपल इफेक्ट क्या मतलब वहां पे कोई इवोपरेटर्स को ऐड करने का कॉस्ट नहीं आएगा क्या? डेफिनेटली आता ही होगा, राइट। और फाइनल कॉस्ट का क्या बता सकते हैं आप? कॉस्ट पे कोई कमेंट नहीं कर सकते, नोबडी कैन आस्क यू एनीथिंग अबाउट द कॉस्ट, ओके, सो लीव इट, डोंट वरी, okay, but yes, you can comment about a particular cost that as compared to single effect, the cost of steam in multiple effect will be definitely less. Why? Because the same kind of steam is producing more vaporization. Now there comes another concept which is called there is a limitation actually of multiple effect. There is a line written in standard books, like if you follow McCabe, there is a line written, उन्होंने explain नहीं किया है but उसको समझना पड़ता है conceptually, that in multiple effect evaporators, we get advantage of higher steam economy, but we have to bear a loss. We have to bear a cost. आपको higher steam economy मिल तो रही है, but to get this higher steam economy, you have to bear a loss. And what is that loss? Is lower capacity. Now, how we can say that we have a lower steam capacity in case of multiple effect evaporators? So for talking about that, before going to lower steam capacity in multiple effect evaporators, let us do one thing. Let us try to understand first what is the, मैं उसके बाद ही explain कर पाऊंगा that what are the various configurations. अभी इतना समझ लेते हैं, ठीक है? मैं I'll come back to this point because otherwise I'll have to use some terms which you can only understand if you know what are the various feed configurations. And one more thing, which is बॉइलिंग पॉइंट एलिवेशन। तो एक बार ये बॉइलिंग पॉइंट एलिवेशन समझा लूँ आपको, है ना। एंड आफ्टर दैट आई विल वेरीफाई दैट इन मल्टीपल इफेक्ट इवापोरेटर्स यू हैव मोर स्टीम इकोनॉमी एज कंपेयर टू सिंगल इफेक्ट, बट लेस कैपेसिटी एज कंपेयर टू सिंगल इफेक्ट। तो यहां तक एक बार समझ ले, देन थ्योरी ऑफ इवापोरेटर्स विल बी कंप्लीट। देन आई टेल यू दैट हाउ टू राइट mass and energy balance on a single effect evaporator. The designing of evaporators, I mean calculation of area of evaporator, what is the main equation for that for that designing is the heat transfer in the evaporator is the overall heat transfer coefficient. Now for most of the evaporator problems, overall heat transfer coefficient is provided to you, right, multiplied by area and then the temperature driving force. So area we have to calculate, right? I told you that it will be provided to you if there is a numerical on evaporator. evaporators पे क्वेश्चन बहुत लेस फ्रीक्वेंटली आते हैं, है ना, बहुत कम आए हुए, बट आ सकते हैं, राइट। सो इसलिए इसको आपको लास्ट प्रायोरिटी पे पढ़ना है। इससे पहले जितनी भी चीज़ें बताई आपको, और फ्रॉम ऑल दोस टॉपिक्स देयर विल बी डेफिनेटली अ क्वेश्चन. कंडक्शन, कन्वेक्शन, रेडिएशन, राइट, ट्रांजिएंट कंडक्शन, देयर विल बी अ क्वेश्चन. बट इवापोरेटर इट्स अ चॉइस, समटाइम्स देयर वोंट बी एनी क्वेश्चन फ्रॉम इवापोरेटर, राइट. तो जितनी ज़रूरत है बस उतना पढ़ेंगे. यहाँ पे ये थोड़ा सा आपको कंफ्यूज करता है कि डेल्टा टी में क्या लेना है. See, delta T is the temperature driving force, means that temperature difference which is used for heat transfer. Now who is heating? What we are using for heating, that is the steam, है ना. तो मतलब जब UA delta T लिखोगे then definitely UA and delta T will be, first should be, because which is at a higher temperature, steam definitely, and that should be temperature of the steam, right, because heat is getting transferred between the steam and the liquid which is present inside the evaporator. So देखो, जिसके बीच में हीट का ट्रांसफर हो रहा है उसी का टेम्परेचर डिफरेंस लेंगे, बिकॉज हीट इज गेटिंग ट्रांसफर्ड. वन इज द स्टीम विच इज हैविंग द टेम्परेचर T steam, right, minus what is the second liquid which is receiving the heat is the liquid which is present in the evaporator. Now what is the temperature of that liquid? That liquid is always assumed to be at the the temperature, because आपको पता है, देखो भाई, इवापोरेशन होने के लिए उसको पहले आप बॉइलिंग पॉइंट पे होना पड़ेगा. सो दैट लिक्विड, व्हाट इज द टेम्परेचर ऑफ दैट लिक्विड, वी विल राइट दिस एज TBP. ये ध्यान रखना है. कई बार स्टूडेंट्स क्या करते हैं, दे टेक डेल्टा T एज आई थिंक सम देयर आर, बिकॉज इन इवापोरेटर न्यूमेरिकल्स देयर आर वेरियस टेम्परेचर्स गिवन. तो आप किसी भी दो टेम्परेचर को लेकर डेल्टा T बना देते हो. Delta T is always the temperature difference between steam temperature and the I'm sorry, steam temperature and the boiling point of that liquid. Now, in while solving the problems, many times we say that steam is available at a particular pressure, and at this pressure the saturation temperature of the steam is this. तो दैट saturation temperature of the steam is we say that this is T steam. What is TBP? TBP is basically the boiling point of the feed mixture, जो भी feed है, feed mixture का boiling point, and of course this feed mixture boiling point depends upon the pressure. Evaporator के अंदर कुछ pressure होता है, right? Evaporator, I'll tell you about this when we will discuss this multiple feed. Evaporator is always operated under some pressure. So the boiling point of the feed corresponding to what? Corresponding to the pressure inside the evaporator. Corresponding to the pressure inside the evaporator. ठीक है? Pressure inside evaporator. उस pressure पे evaporator का जो भी boiling point होता है inside evaporator, that is TBP. What is T steam? It is the temperature at which steam is present. Many times steam is saturated, and that's what I was saying, that steam many times gives the latent heat only. So many times steam is saturated. और आपको क्वेश्चन में डेटा ऐसा दिया रहेगा that steam is available at this much pressure. Steam का pressure, evaporator का pressure नहीं लिख देते हैं. Many times, mostly saturated steam is used. You understand what is saturated steam? It only has the latent heat to give, right? Saturated steam is used. Okay, saturated steam is used. Okay, so in this case, this kind of data is given. आपको इस तरह के डेटा का यूज करना आना चाहिए. देखो, steam is available at some pressure. Suppose at, let's say, मैं just directly example दे रहा हूँ ताकि आपको चीजें आराम से समझ आए. At some pressure at Pset at, let's say, 100 kilopascal और कुछ ऐसा. Just an example. The saturation temperature Tsat at 100 kilopascal is, let's say, 130 degrees Celsius. This is the statement. So in this statement, if I ask you what is temperature of the steam, you'll say that from this statement you can easily write that temperature of the steam is 130 degrees Celsius. This ये ध्यान रखना है कि delta T में कौन कौन आता है. Now you must have read in your 11th 12th class that there is a term called, when you make a solution comprising of liquid and solid, है ना, आपने solute को लिया, solid solute, not liquid, solid solute you dissolved in a liquid, then we have studied the colligative properties, right? Colligative properties means reduction in vapor pressure, elevation in boiling point, depression in freezing point and osmotic pressure होता था ना. तो there was a property called elevation in boiling point. Whenever you make a solution of solid solute dissolving in a liquid, there is the elevation in boiling point. Right down. When a solid is dissolved in liquid, when a solid is dissolved in liquid, elevation in boiling point is observed, right? Elevation in BP is observed. और एक चीज आपने देखा होगा कि colligative, this elevation in boiling point is a colligative property, and colligative property is a property which is dependent on the number of particles. मतलब अगर आप solute बढ़ाते जाओगे, colligative property will be more and more, right? Means boiling point elevation, इसको short में BPE लिखते हैं. Boiling point elevation is more significant in concentrated solution. In concentrated, कई बार स्टूडेंट कहते हैं कि सर ये क्या था, समझ नहीं आया. देखो इसमें समझाने जैसा है नहीं. बॉइलिंग पॉइंट एलिवेशन मींस आपका सपोज वाटर हैज द बॉइलिंग पॉइंट कॉन्सेंट्रेटेड सॉल्यूशन, और डाइल्यूट सॉल्यूशन के लिए उतना सिग्निफिकेंट नहीं होता. ऑब्वियसली हाउ यू आर गोइंग टू बॉइलिंग पॉइंट नो द बॉइलिंग पॉइंट एलिवेशन? फर्स्ट ऑफ ऑल, सी व्हाट इज द मीनिंग ऑफ बॉइलिंग पॉइंट एलिवेशन? इंक्रीज इन द बॉइलिंग पॉइंट. द वाटर इज हैविंग अ बॉइलिंग पॉइंट ऑफ 100. Suppose you make a solution of salt and water. If the concentration of salt is suppose very low, dilute solution suppose 2% or 3%, still that solution can have a boiling point of 100 degrees Celsius. But if the solution is concentrated, let's say 25% solution of salt and water, definitely its boiling point will be more than 100 degrees Celsius, and that difference is called boiling point elevation. Simple, right? One more thing, that how can you determine boiling point elevation by a formula? No, it has to be provided in this. Otherwise, there are tables, there are charts called During charts. DUHRING. लिख लो. Obtained from BPE determined. आपको ये चार्ट पढ़ने के लिए नहीं आएगा एग्जाम में, डोंट वरी, बस नाम के लिए. अगेन फॉर्मेलिटीज, राइट, इज determined from ड्यूरिंग रूल्स और ड्यूरिंग चार्ट्स आपको जो बोलना है बोल लीजिए, ठीक है, ड्यूरिंग चार्ट्स, अदरवाइज it is directly provided to you. But BPE, is it good for us, is it bad for us? What is the problem with BPE? The thing is, I'm saying that Q is written as UAT, steam minus boiling point of this solid, right? Suppose if the solution, boiling point of the solution, suppose if the solution is concentrated, then definitely if BPE is significant, how much, मतलब किसको significant बोलेंगे, किसको नहीं बोलेंगे, सीधी सी बात है, if it is provided in the question, it is significant, otherwise ignore it. If BPE is significant, then definitely the boiling point is going to increase, significant. Now if boiling point increases, what do you think? If boiling point increases, the driving force for temperature, this heat transfer driving force, this driving force, भाई ये बढ़ गया है ना भाई. You have earlier you were having 130 minus 100, now you are having 130 minus 110. The driving force decreases, and that is the bad news. Okay, so if BPE is significant, Q is equal to UA, temperature of the steam, minus TBP plus BPE. ये TBP यही वाला TBP, ये मत बोलना कि सर दिस इज इंक्लूडिंग BPE. नो, अगर इंक्लूडिंग होता तो मैं अलग से क्यों लिखता है ना. दीज आर बेसिक थिंग्स यू शुड अंडरस्टैंड. ओके, so boiling point elevation is there, suppose 5 degrees Celsius or 10 degrees Celsius elevation, it can be this much significant also, and this much reduction, it is going to reduce the driving force for heat transfer. So less heat will be transferred, obviously. Less heat will be transferred means less evaporation, right? So this is the role played by boiling point elevation. Less amount of heat will be transferred, and boiling point elevation को इस तरह से आपको इस equation में include करना है, right? Okay. Note down, first of all, note down. Right. Now, I was saying that in evaporators, when we use multiple effect evaporators, we have more steam economy, but there is a loss, right? But before talking about that loss, let us talk about the various configuration of multiple effect evaporators. So there are 4 configuration. ये आप लिख लो, मैं erase करता हूँ इसको. There are 4, actually they are called the types of arrangement of evaporators. Put the heading, types of arrangement of evaporators. ठीक है, टाइप्स ऑफ अरेंजमेंट ऑफ इवापोरेटर्स. आप यहाँ राइट साइड में आपको यहाँ डायग्राम दिख जाएगा, डायग्राम आप बना लो, ठीक है. आपको ज्यादा कॉम्प्लेक्स डायग्राम बनाने की जरूरत नहीं, जस्ट फॉर गेटिंग एन आइडिया, राइट. सो टाइप्स ऑफ फीड अरेंजमेंट, टाइप्स ऑफ फीड अरेंजमेंट. और ये जो टाइप अरेंजमेंट है ये मल्टीपल इफेक्ट नहीं होंगे, सिंगल इफेक्ट में अरेंजमेंट का कोई मतलब नहीं है. टाइप ऑफ फीड्स अरेंजमेंट इन मल्टीपल इफेक्ट इवापोरेटर्स, मल्टीपल इफेक्ट इवापोरेटर्स. ओके, सो देयर आर 4 फीड अरेंजमेंट्स बेसिकली. आपको एक एक करके सारे फीड अरेंजमेंट से आप दिख रहे हैं, आप स्क्रीन पे देखो, पॉज करके डायग्राम बना लेना. द फर्स्ट वन इज फॉरवर्ड फीड. फॉरवर्ड फीड. What are the features of this arrangement? As you can see in this diagram right now, the feed enters in the first effect. और देखो first effect उसको नहीं कहूंगा जहां पे feed जा रहा है. Steam is entering the effect, and that effect is the first effect, and in the same effect feed is entering. So feed enters, feed and steam, we can say that feed and steam enters the same effect. अच्छा, ऐसा नहीं है. सपोज आप इस सपोज इंस्टेड ऑफ द फ्रॉम लेफ्ट साइड यू कैन ऑल्सो एंटर द फीड फ्रॉम द राइट साइड एंड स्टीम ऑल्सो फ्रॉम द राइट साइड. दैट विल ऑल्सो बी कॉल्ड एज फॉरवर्ड फीड अरेंजमेंट. मीन्स फीड एंड स्टीम आर एंटरिंग द सेम इफेक्ट. सो दैट इज द फर्स्ट पॉइंट, दैट फीड एंड स्टीम एंटर्स द सेम इफेक्ट. ठीक है, एंटर्स द सेम इफेक्ट. Feed and stream enters the same effect. That is the forward feed arrangement. Okay, जिस मैंने पहले बता देखो मल्टीपल इफेक्ट में जहां पे स्टीम एंटर किया, that is the first effect. Okay, pressure P decreases. In the first effect, pressure is high, and as you go from 1 to 2nd to the 3rd effect, pressure decreases from 1st to 3rd effect. First to the effect to the next effects. Okay, this you must know that pressure decreases from first to next effect. ये हमेशा होगा, not only in forward feeds. See from where the steam is entering, that effect is having the highest pressure, and that should be called as the first effect. The next effect should have the low pressure, and the next effect should have the lower pressure, like that. Okay, so pressure decreases from first effect to a last effect, and this is common in all. Ye likh lo, this is common for all configurations. Common for, so pressure decreases in the direction of flow of the steam. So common for all configuration. So what is the specific point about this? Say, it means if suppose, and this is the simplest kind of multiple feed arrangement, forward feed. Diagram dikh raha hai, diagram bana lo. It is obvious that if pressure is decreasing from the first effect to the second effect to the third effect, then for the flow of steam from first to second, or for the flow of liquid from first to second, pump will not be required. है ना, क्योंकि delta P already available है. If delta P is there, from first effect to the second effect, the steam and the liquid can flow on its own. हाँ, pump लगाना नहीं लगाना, that is something else. Theoretically, pump is not required. There is already a decrease in pressure, the liquid will flow automatically. From second effect to third effect, there is a decrease in pressure, so again no pump is required. मैं तीन effect का example लेके चल रहा हूँ, but suppose from third to fourth again there will be no pump required. But suppose no pump required, so of course I can save some cost of pump. I can't comment about the total cost. No pump is required, right? No pump is required for say for first effect to second effect, मतलब steam या liquid किसी को भेजने के लिए, and for second effect to third effect. Obviously pump will be required for pushing the liquid into the first effect and for taking out the liquid from the third effect. Pump will be required. Pump will be required for pushing the liquid or feeding the liquid in the first effect. मतलब feed को पहले में भेजना है, वहां कुछ pressure का तो role है नहीं. Pump has to be there. Liquid in first effect. Correct? While and taking out concentrated liquor from the last. Concentrated liquor from last. Correct? So pump is not required between the effects, but for the first effect and the last effect pump is required. तो अब ये बोलोगे कि सर ठीक है, कहीं पंप बचेगा और कहीं पे पंप लगेगा, definitely it will be there, right? So that was the first kind of arrangement. इतनी चीजें आपको यहाँ पे पता होनी चाहिए. Yes, definitely economy is more than the single effect. अब आप बोलोगे सर वो capacity वाला समझा दो. So definitely I'll come to the capacity. या एक काम करते हैं, इसी में समझा देते हैं. देखो, capacity compare करना है. I want to compare the capacity of multiple effect evaporators. See, but again I am having some assumption. Suppose there is one effect, right? There is one effect, single effect, right? This single effect has area A, overall heat transfer coefficient U, and the overall temperature difference delta T. Now what is the heat transferred? Q is equal to U A delta T. Correct? देखो capacity is I'm assuming that capacity is proportional to heat transfer. बस जितना ज़्यादा heat transfer करूँगा उतना ज़्यादा water evaporate होगा. So for single effect, capacity is this proportional to this Q, which is UA delta T. Let's say I have multiple effects. अब जब multiple effect की आप बात करते हो, तो multiple effect if it is having area A, this multiple effect is also having area A. कई बार students सोचते हैं कि सर A by 3 कर दो, 3A कर दो. No, it is also having area A and area A. Correct? But what is same is the temperature difference. The net temperature difference is delta T, right? So this is, let's say, T1, this is T2, this is T3, this is T4, and this T1 minus T2 plus T2 minus T4 plus T3, sorry, plus T3 minus T4, right? So what is the net temperature difference is T1 minus T4 is the net temperature difference, and the same temperature difference I'm maintaining here, T1 and T4. So temperature difference same रहता है. So if I ask you that what is the heat transfer rate across all these three heat exchangers, right? You'll say कि sir across these three heat exchangers, सो आई एम रिमूविंग दिस डायग्राम, पहले डायग्राम हटा लेता सो दैट थोड़ा सा स्पेस यहाँ पे यूज हो जाए. एंड ऑफ कोर्स आई एम अज्यूमिंग किसी भी मल्टीपल इफेक्ट की बात कर लो, ठीक है, आई एम अज्यूमिंग फीड फॉरवर्ड काइंड ऑफ फीड अरेंजमेंट ऑफ द इवेपोरेटर्स. What is the thing that, first of all, I'm assuming that this is having area A and each effect is having the same area A. Area change nahi karna hai, but we are having the same temperature difference across these three effects and the same temperature difference is existing here for the single effect. Okay. So what is the amount of heat transfer? We say that the amount of heat transfer is equal to UA T1 minus T2 plus UA T2 minus T3 plus UA T3 minus T4, correct? And ultimately you are getting this as UA T1 minus T4, and the same here is UA T1 minus T4. So what do you observe? You observe that multiple effect evaporator में capacity तो बराबर है. Why I said less? It means, but there is a factor. See, capacity, it seems that capacity in a multiple effect evaporator is equal to the capacity of single effect evaporator, okay, capacity of single effect evaporator. ये ठीक है. मल्टीपल इफेक्ट इवेपोरेटर की कैपेसिटी एंड सिंगल इफेक्ट इवेपोरेटर की कैपेसिटी दे आर सेम. इट सीम्स लाइक दिस फ्रॉम दिस मैथमेटिकल कैलकुलेशन. यस, देखो, मल्टीपल इफेक्ट कैपेसिटी एट मैक्स कैन बी इक्वल टू सिंगल इफेक्ट कैपेसिटी, कैन नॉट बी ग्रेटर, राइट? बट देयर कैन बी अ केस. बट इफ boiling point elevation is significant, suppose boiling point elevation significant, and you know that as the concentration increases it becomes more and more significant, then you'll write that Q is equal to U A this T1 minus T2. T1 is the feed temperature, suppose, right? Or T1 is this temperature. Then the net driving force available, if boiling point elevation is significant, then the net driving force available will not be equal to, it will be less than T1 minus T4. Then, write down, सीधा लिख लेते हैं, significant, then net delta T available. ये आपको समझ आ रहा है ना? मैंने आपको यहाँ पे BPE का बताया था. What is the role of BP? It decreases the delta T. So if BPE is significant, then in each effect this delta T will be less, then further less, and then further less. So the sum will not be equal to this delta T. Okay, then the net delta T available will be less than T1 minus T4. और अगर net delta T available है तो Q less हो जाएगा. In this case, multiple effect, and you know boiling point elevation, in case of multiple effect evaporators, at least boiling point elevation is always there. In this case, capacity of multiple effect evaporators will be reduced. Capacity of multiple effect evaporators will be reduced. Okay, this is the explanation. So matlab, what is the net conclusion? That at max a multiple effect evaporator can have capacity equal to the single effect evaporator when the boiling point elevation is not significant. But when the boiling point elevation is significant, and which is in most of the cases, the multiple effect evaporator will give you higher economy but less capacity. So यहाँ से statement आता है that in multiple effect evaporator we obtain, in multiple effect evaporators we obtain higher steam economy, higher steam economy on a cost of economy at a cost of lower capacity. ठीक है, at a cost of lower capacity. तो कैपेसिटी लो कर देते हैं, लेकिन कैपेसिटी लो हो जा रही है बट स्टीम इकोनॉमी इज मोर. यहां से ये स्टेटमेंट निकल के आती है. नाउ इसको इरेज करते हैं. लेट अस डिस्कस अबाउट द अदर फीड अरेंजमेंट्स. वन इज another one which is quite common is the backward feed arrangement. Means You can see the diagram. एक बार यहाँ लिख erase कर लेते हैं. Then you can see the diagram. Okay. Now the next one is the backward feed arrangement. Okay. So put the heading. ये theoretical चीजें हैं जो क्वेश्चन जहां से बन सकता है. तो आपको पता है, देखो यार, ये इवेपोरेटर पूरा पढ़ने में आपको 2 घंटे लगेंगे. ठीक है, छोटे छोटे टॉपिक्स है, इनके लिए ज्यादा लोड नहीं लेना है. Only 2 hours are sufficient for going through all this discussion, right? And of course you have questions in test series, you can practice them, right? So second one is backward feed arrangement. So in this case also, see, steam will enter that effect which is called which will be called as first effect, and it will be having high pressure. ये common है, right? So the feed enters the last effect. You can see the diagram. The feed enters the last effect. Last effect means the effect in which the pressure is lowest. Last effect, you know, the pressure is lowest because the pressure is highest in the first effect where the steam is entering. मतलब steam की entrance और feed की entrance opposite case से हो रही है. तो आप बोलो सर ऐसा क्यों करेंगे? The feed enters the last effect. First of all, pump की बात कर लेते हैं. Now in this case, the feed will be traveling from low pressure to high pressure effects, and therefore pump will be required in each and every effect, right? So you can write down that the liquid will travel. Steam के लिए तो नहीं चाहिए होगा. Steam is going from one effect to high pressure to low pressure. The liquid is traveling from low pressure effect, to high pressure effect, and hence pump will be required in each case. Now the question arises ki sir, in which situation we can go for backward feed arrangement? See, sometimes when you know that as the temperature increases, the viscosity of a liquid decreases. This is the general, you know, that as the temperature increases, viscosity of a liquid decreases. What is the problem with viscosity? There are various problems. If the liquid is highly viscous, then first of all its pumping is difficult. First of all, if liquid is more viscous, its pumping cost is more. Secondly, if liquid is viscous, means and which liquid is viscous? If suppose the concentration is very high, it will be viscous, right? For highly viscous liquid, it is difficult for us to pump the liquid. Plus, right? Plus, see, suppose if your feed is viscous, then what is going to happen? If feed is viscous, for viscous fluids, see, consider the scenario. See the diagram, consider the scenario. Let us discuss about the opposite case. That suppose we are having viscous fluid and I am using the forward feed arrangement. मतलब अगर viscous fluid में मैं forward feed arrangement करूँगा, then you know that as the evaporation is taking place, what is going to happen? The concentration is increasing, right? The concentration is increasing, correct? And also in the forward feed arrangement, the last effect will be having you know, very low temperature. So as the more and more evaporation is taking place, the feed is becoming more and more viscous, and also temperature is decreasing, so the feed is further becoming viscous, right? The feed is further becoming viscous, and ultimately what is happening, as more evaporation is taking place, the viscosity of the fluid is increasing. और उसको support करने के लिए एक और चीज आ गई, decrease in temperature. So the decrease in temperature is also helping to increase the viscosity. That is not good for us. Viscous fluids are difficult to pump, right? But if I use backward feed arrangement, then see what is the advantage. आप बोलोगे सर backward में भी तो evaporation होगा. In backward feed arrangement also more and more fluid will be evaporated, right? Backward feed में भी evaporation होगा, right? And due to which viscosity will increase. But in the backward feed arrangement, the liquid is first entering low temperature, then high temperature, and then high temperature. So one factor, एक factor तो क्या हुआ कि जैसे जैसे evaporation हो रहा है, viscosity is increasing, but as the temperature is also increasing, it is trying to cancel out the effect of increase in viscosity. तो दोनों opposing factor. So for viscous fluids, backward feed arrangement is used. Backward feed arrangement is used. Feed arrangement is used. Because why? Because the most concentrated, ये line लिखी होती है books में. Why? Because they say that the most concentrated liquid is present at the highest temperature. इससे क्या होगा? अच्छी बात है, because most concentrated liquid is having more viscosity, but if it is present at high temperature, then the increase in temperature will try to lower some effect. भाई थोड़ा कुछ तो lower होगा as compared to before, right? So feed arrangement, because the most concentrated, because most concentrated liquid is present at the highest temperature. Is present at highest temperature, and this tries to reduce the viscosity. तो एक केस है viscous fluids के केस में backward feed arrangement is preferred. One more case is there. If the feed is cold feed means it is below the bubble point. If feed is cold, then also backward feed arrangement is preferred. Then also backward feed arrangement is preferred. Arrangement is preferred. Why? What do you think? Arrangement is preferred. Simple explanation. देखो, if feed is cold and suppose आप इसमें forward feed arrangement use कर रहे हो. Feed is cold means it requires some heat to go to the boiling point. अब अगर आप इसमें forward feed arrangement use कर रहे हो, it means for cold feed some heat will be required, right, to increase the feed temperature to the boiling point. और ये heat किससे लेगा? Steam से लेगा, because in the first effect steam is entering. So some heat will be taken by the steam to increase the temperature of the cold feed to this boiling point. So definitely less, less steam will be available. Less heat will be available from the steam for evaporation. So less evaporation will be there definitely. Less evaporation leads to less economy, right? Because kg steam used, kg water evaporated, less economy. But suppose if I use backward feed arrangement, then this still some heat will be required, but that heat will be taken from some vapor released in this the previous effect, right? जो पहले effect में जो steam है वो तो अपनी पूरी की पूरी heat दे रही है. If I'm using backward feed, then in the first effect, the steam is not giving heat to increase the temperature. It is giving its entire heat for the evaporation, right? So definitely we are having some advantage of saving the energy of steam when we are using a backward feed arrangement in the case of cold feed. तो आपको ये याद रखना है कि viscous fluids and cold feed के लिए backward feed arrangement is more suitable. Apart from forward and backward, now you can see the two more cases. One is called mixed feed arrangement. Now what happens in the mixed feed arrangement? That the feed enters in some intermediate effect. But suppose we have 4 effects, right? The feed will enter in the third effect. From the third effect, it will travel to the fourth like the forward feed arrangement. And from the fourth effect, it will come back, right? And then it will come back to the second effect and then go to the first effect, then come out. Means some part from third effect to fourth effect, it's kind of forward feed. And then from fourth to back to second and then first, it's kind of backward feed. So forward or backward feed ka mixture, that is called mixed feed arrangement, right? Another one is called parallel feed. In parallel feed, feed enters in each and every effect, right? और इसमें से जो लिक्विड बाहर आएगा पैरेलल फीड में से वो दूसरे इफेक्ट में नहीं जाता, उसी में से बाहर निकल आता है, राइट? दीज आर सम अदर अरेंजमेंट्स. अब इनके लिए ज्यादा डिटेल में जाने की जरूरत नहीं कि कब यूज करते हैं, स्पेसिफिक केसेस में इनको यूज किया जा सकता है. दिस वाज द डिस्कशन रिगार्डिंग द टाइप्स ऑफ फीड अरेंजमेंट इन केस ऑफ इवेपोरेटर्स. ओके, नाउ व्हाट इज रिमेनिंग इज द बैलेंस ऑन इवेपोरेटर फॉर डिजाइनिंग, जहां से आपके पास न्यूमेरिकल्स आते हैं. ठीक है, ये बैलेंस थोड़ा ध्यान से देखना, ज़्यादा मुश्किल नहीं है. यू ऑलरेडी हैव डन द मटेरियल एंड एनर्जी बैलेंसेस, सो इट वॉन्ट बी वेरी डिफिकल्ट फॉर यू. सो ओके, एनर्जी एंड मास बैलेंस ऑन इवेपोरेटर्स एंड मास बैलेंस ऑन इवेपोरेटर्स. ओके, see energy and mass balance on evaporators. See, suppose this is an evaporator, just random diagram. मैं आपको सिंगल इवेपोरेटर का बैलेंस बता रहा हूं. एग्जैक्टली सेम कैन बी अप्लाइड टू मल्टीपल इफेक्ट इवेपोरेटर्स, राइट? कॉन्सेप्ट नहीं बदलेगा मल्टीपल इफेक्ट इवेपोरेटर्स में। नाउ यू हैव 3 सिस्टम। आपने प्रोसेस कैलकुलेशन में क्वेश्चन नहीं किया क्या 1 यूनिट एंड 3 यूनिट्स, सेम गोज विद द सिंगल इफेक्ट एंड मल्टीपल इफेक्ट। ओके, सपोज दिस इज एन इवेपोरेटर, राइट? The pressure inside the evaporator is some P1. This is single effect, so P1 pressure. Feed is entering the evaporator. Okay, so feed is entering and it is having a flow rate of F kg per hour, right? It can have the enthalpy of HF, correct? It is having a temperature of TF and having mass fraction of XF. सारी चीजें लिख दी, जिसकी जरूरत पड़ेगी उसका यूज कर लेंगे। Okay. Steam is also entering, right? This is steam. What is the flow rate of steam? S kg per hour. Okay. What is the temperature of the steam? T steam. The steam has latent heat of lambda. इसको lambda s से denote किया जाता है. It is having the latent heat of lambda s kilojoule per kg and it is used to heat. At a pressure P1, suppose the boiling point of this liquid is T Bp. ठीक है? अगर elevation है, then I should add the elevation here in this T Bp, right? And from here, vapors are leaving. Let's say that the vapor flow rate is V, right? The enthalpy of vapor is HV. अब small h use करते हैं, capital, वो आपने थर्मो में पढ़ा होगा, you can do that. What else? VHV, and this liquid is the concentrated liquor which is L, having the enthalpy HL. ठीक है? अब देखो, कुछ आपको rules मैं बता दूं यहाँ पे, that suppose if TBP, for solving most of the problems, we take TBP as the reference temperature. We always assume that this liquid is leaving at a temperature equal to the boiling point of this liquid under this pressure. ठीक है? So what are the rules? TBP should be taken as the reference temperature. For solving, अगर आपको reference temperature की जरूरत है, then TBP should be the reference temperature. One thing. Secondly, the liquor leaving, concentrated liquor is assumed to leave at a temperature TBP. That is the second point. ये याद रखना. Even vapor is assumed to leave at the same boiling point temperature, right? So I think I have discussed everything here. This is the scenario, right? Suppose heat transfer coefficient is U and area available for heat transfer, because steam इसमें direct mix नहीं हो रहा है, indirect heat exchange हो रहा है. Steam and this liquid, the area available is A. Now how you are going to write the balances? First of all, mass balance. Writing mass balance is quite simple. और एनर्जी बैलेंस लिखने के लिए आपको ये देखना पड़ेगा that what kind of data is given in the, बहुत इजी सी प्रॉब्लम है. इवेपोरेटर्स बच्चे कई बार, मैं आपको बताया गलती कहाँ होती है. एक तो गलती होती है डेल्टा टी लिखने में. डेल्टा टी में पता है क्या करते हैं? दे टेक दिस डिफरेंस TF minus TB. हाँ, they take the difference. I have seen many times they take the difference TF minus TB as the delta T. भाई इन फीड और इसके बीच में हीट ट्रांसफर हो रहा है क्या? डेल्टा T तो आप उसी के बीच का लोगे ना जिसके बीच में हीट ट्रांसफर हो रहा है, राइट? सो हाउ टू राइट? फर्स्ट ऑफ ऑल मास बैलेंस. All of you I think are comfortable with mass balance. Mass balance, which is F is equal to V plus L and FXF is equal to, अच्छा ये FXF किसका बैलेंस है? सॉलिड का बैलेंस है ना. XF is the mass or weight fraction of solids. You know that we have to assume that vapor never has solids. ये कुछ बेसिक बातें हैं, ये आपको पता होनी चाहिए. क्वेश्चन में कभी इंफॉर्मेशन नहीं होगी, राइट? Vapor never had any solids, so V into 0 plus LXL. This we have done in process calculation. It's not a new thing for us, right? Energy balance, steady state balance लिखना है, right? No shaft work, okay? No shaft work and kinetic potential energy changes neglected. So energy balance at steady state. Say depends that what kind of data is given to you. अच्छा एक चीज समझो, कई बार मैंने देखा है कि that student क्वेश्चन में क्या होता है ना, क्वेश्चन में डायरेक्टली इंथैल्पी दे दी, इंथैल्पी इज गिवन एंड द स्टूडेंट इज लुकिंग फॉर सीपी. सर सीपी का है, सीपी का है, सीपी का. व्हाई टू लुक फॉर सीपी? सपोज let me take one more data here. The Cp is Cp. And suppose Cp is constant for this. If it is not constant, it should be provided. Let's say this is also having specific heat Cp, this is also having specific heat Cp. लेकिन एक बात होता है, अगर आपको इंथैल्पी ऑलरेडी दे दी है, then why to look for Cp? भाई Cp का क्या करोगे? Cp specific heat is used to mCp delta T. You use to calculate enthalpy. But if enthalpy is directly given to you, HF, HV, HL is directly given to you, why to write mCp delta T? ये मैंने देखा है कि बच्चों यही नहीं पता यार कि mCp delta T तो enthalpy निकालने के लिए यूज होता है ना. So if enthalpy is given directly, these are actually molar enthalpies, right? These are, let me write this in the form of cap, because you are familiar with this notation. These are specific enthalpies. If specific enthalpies is given, for it is multiply कर दो ना, total enthalpy आ गई. What is energy balance? Okay, no, sorry. Delta H is equal to Q external, because this is not adiabatic. The same equation जो process calculation में पढ़ा था वही है. तो कई बार ये delta H is equal to Q external नहीं लिखता हूं तो बच्चे सोचते हैं सर evaporator का energy balance अलग है. See, energy in plus energy added is equal to energy out. यही तो है. See, delta H, what is delta H? Energy out minus energy in is equal to Q external. Q external is the heat which I am adding from here. हो गया question खत्म. See, enthalpy in, what is enthalpy which is entering the system? F into HF. Suppose if enthalpy is directly given to you, then write the balance like this. This is entering plus what is entering? The energy is entering. This is Q external. This is the energy entering in the form of heat transfer from the steam. तो कैसे लिखोगे? steam से कैसे heat transfer हो रहा है? U A T steam minus TBP. Correct? FHF प्लस UA T steam, यही हो रहा है ना भाई, T steam माइनस TBP. अगर एलिवेशन है तो BP में BPE ऐड हो जाएगा. इज इक्वल टू एंथैल्पी लीविंग. व्हाट इज एंथैल्पी लीविंग? V मल्टीप्लाइड बाय HV कैप प्लस L मल्टीप्लाइड बाय HL कैप. हो गया? VHV कैप प्लस L HL कैप. हो गया एनर्जी बैलेंस. कितना मुश्किल है ये, right? One more, this is one equation, but please note that we can use this equation only if the enthalpies are directly provided. But if enthalpies are not directly provided, if enthalpy provided nahi hai, but you have the specific heat and temperatures, if enthalpy is not provided directly, not provided, but we have temperatures and CPs, अलग अलग CP हो या same CP हो, in that case, you know, mCp delta T. What is the enthalpy of feed in this case? M, flow rate, CPF. What is the temperature? TF, na? TF. Now the question arises that what should be the reference temperature? So I gave you a rule that reference temperature should be TBP. इसीलिए कई बार आप delta T लिख देते हो, TF minus TBP is the delta T. No. So that is the TBP is the reference for defining enthalpy. So I am writing TF minus TBP, right? Plus steam, right? So what is the heat transferred? UA, ये तो TS minus TBP, right? That is equal to, what is the enthalpy of this? Suppose the flow rate is V. What is the enthalpy of this one? Yeah, the enthalpy should be, this is the condensation of the steam, this is VHV, there is nothing, there is enthalpy only, V into HV, there is nothing else. V into HV. भाई इसको कई बार आपके पास डेटा दिया होता है enthalpy of vaporization of the liquid, that enthalpy of vaporization is this. So V into HV. And what about this? See, I have considered this as my reference TBP. So what is the enthalpy? Zero. भाई reference की enthalpy क्या होती है? हमेशा zero. So either we use this equation depending upon the data, or I use that equation. One more thing that later either you, देखो दोनों use नहीं होंगे, either I will use this equation or this equation. Apart from this, I will also use this equation. UA T steam minus this is T steam. This is the heat transferred by the steam, and this should also be equal to the flow rate of the steam minus latent heat of condensation of the steam. ये भी तो एक equation है ना? This is equation number 3. For solving evaporator problem, either these two will be used or these two will be used. That's it. हाँ, आप बोलोगे कि सर क्या मैं इसकी जगह ये लिख सकता हूँ? हाँ, लिख सकता हूँ. डिपेंडिंग अपॉन की क्वेश्चन सही. कई बार क्वेश्चन में क्या पूछता है? दे आस्क यू द स्टीम consumption, how much steam will be used. So why do you write this equation? Just write S lambda S instead of this. Sometimes they ask you heat transfer area, then why to write this, right? This equation. बहुत simple balance है, कोई दिक्कत नहीं इसमें. क्वेश्चन को ठीक से पढ़ो. What is given? Apply the proper energy balance. This was about the energy balance on the evaporator, and the same energy balance can be applied when there are multiple effect evaporator also. इतनी डिस्कशन आपके लिए evaporator के लिए sufficient है. इतनी डिस्कशन करने के बाद आपके पास गेट में there are hardly, I mean, you will find 4-5 numericals hardly in the past few years. Even if you take, let's say 30 years papers, you'll hardly find 5-6 numericals on evaporators. All of them you will be solved by whatever information we have provided to you in this topic, right? So this was all about evaporator from my side. Just go through this. It will hardly take 2 hours of your time, and then evaporator part is done.